Now, in this session, we're going to talk about digital circuits and digital information. And this is one thing that I think is a crucial idea for any sort of computer engineer or anyone who's doing computing architecture. So the first idea is well, what are we trying to do when we program a computer? We're trying to take some idea that we have in our head, and we need to translate it into a way that these computing devices can understand, right? Or maybe we're having a conversation and I need to take the language that I'm speaking in and put it into a language that the computer can speak and understand, right? Okay, so computers, while they're able to do a number of wonderful things, are not intelligent like we are. Computers are very basic in that they only speak one language, and that language is bits. All right? Bits. So what are bits? Bits are just strings of zeros and ones. And so if we want to communicate with a computer, if we want to teach it, tell it to do something, to program it, we need to take our ideas, our language, and we need to convert them into bits. And we have to convert instructions into bits, feed that into the computer reads the bits, and then it does what hopefully we want it to do. Okay, so again, bits are just strings of zeros and ones. So the point of this next hour or so will be to familiarize ourselves with some of the ways that bits can be used for programming. And this is the subject of digital circuits and digital information. So digital information means we take information, we encode it into digits of zeros and ones. All right? And this is going to be kind of a hands-on hour here because there's this really nice tool, this SimCert digital circuit simulator here that we can play around with to get a sense of some of these concepts and how actually you can program or how you can give instructions using digital language. So what I want to do is in a separate, or open up your browser, and let's see, this address here. Okay. So here it should look something like this. This is what you should see. Okay, now this is a simulator, which means that we can use all of these guys on the left here, and these are simulating real objects that a computer designer has to work with. So you have DC here, which is your power supply. You have an LED, which is going to be the lights that we'll play with. You have some switches here, push on, push off. And you have a toggle switch. And then below that, you have something which are known as a whole bunch of gates. See this? Not, and, NAND, or, NOR. So all those guys on the bottom are what are known as gates. All right? And this is now just the basic building blocks of any computer design, are gates. Because this is how the computer processes digital information. So what we're going to do is we're going to try to understand how some of these gates behave. And this is using, what we'll do is we'll put together a few truth tables to monitor this. Yeah. First, let's just play around with this. So if you want to grab your DC power supply and you just drag it over there like this. Okay? And then grab a LED light and bring that onto the sandbox, into the sandbox as well. And the way you want to do is when you click on those little circles, you click and hold it down, and that's like dragging a wire. Okay. So, and if you click again on it, it'll make it disappear. So you click and drag to wire it, and then you click on it again, and it disappears. So let's put a toggle switch on there, and let's go from the DC to the toggle, from the toggle to the light. Okay, and so what this toggle does is it's basically like a light switch, right? When this is down, you get the light to light up. All right, now I want to make this connection with bits, okay? Because right now this is just like some sandbox. But remember, bits are strings of zeros and ones. So we can interpret the state of this toggle as also being in a 0 and a 1. Right? When it's pressed, that could be a 1 state. When it's not pressed, it's a 0 state. So what we're observing is a relationship between the state of the toggles and the lights. Right now this is very simple. When the toggle is pressed, 1, the light bulb is on, 1. When the toggle is not pressed, 0, the light bulb is not on, 0. Okay? But we're going to build up more elaborate circuits, and our goal will be to understand the configuration of the toggles, the states of toggles as being zeros and ones, what that causes the state of the lights to be. Okay, so this is going to be just a very general framework for a logical operation of mapping zeros and ones of toggles to zeros and ones of lights. Right now, this would be the identity mapping. When this is 0, this is 0. When that's 1, that's 1.